everyone, we are Team Sigfold. Our project is about labeling relationships based on information cascades. So in order to understand the problem, we have a toy example here of a social network. So on a social network, the nodes are of the same type that are the users. But we argue that the relationships are of different semantics because people make friends out of different reasons. Therefore, the problem is how do we automatically learn the semantics of the relationships? In other words, how do we type the relationships? We notice that there's a lot of information flows on the network. The information is usually modeled by information cascades. For example, a cascade can be a vector of nodes which are infected by that information. And we also notice that the information can be of different topics. For example, some information are more related to science and some are more related to food or sports. Our assumption is that different types of relationships will promote the propagation of different topics of information with different capacities. For example, this table tells us that the academic relationships will promote the propagation of science-related relationships, science-related information with a quite high capacity of, for example, 0.8. But it will promote the propagation of food and sports-related information with a much lower capacity. On the other hand, personal relationships will promote the propagation of food and sports-related information with a much higher capacity. Therefore, on this graph, based on the information of cascades we have, for example, these three specific information cascades, we can try to label the relationships. And on this graph, this is the results we get. Because we see that nodes 1, 3, 5, 6 appear in the information cascades about science, we think that those three relationships are more likely to be academic relationships. And similarly, the other relationships are more likely to be personal relationships. Let's go to some more details of our project. As we discussed before, our main goal is to model the heterogeneous relationships on social networks. This will immediately enable some new interesting applications as well as better modeling of some old applications on the social network, because now we can do it in a relationship type aware fashion. Our first challenge is how do we automatically label the relationship types? As we discussed before, our insight is that different relationship types have different propagation capacities with respect to different information topics. Therefore, we can use information cascades on the social network to label the relationships automatically. In order to do that, we take the input of an original graph G, which includes nodes as users and edges as relationships. We also take the input as a set of information cascades with contents. And then we can do topic modeling on these information cascades to get a set of latent topics C. And according to this topic model, we can assign each information cascade with a unique topic C. And then we propose to use a sparse matrix W to encode the relationship type assignment. We assume that each relationship can have only one type, and each relationship type has a vector of propagation capacities with respect to different information topics. We use a matrix M to encode this information propagation capacities. The component Mij of this matrix M stands for the propagation capacity of relationship type Ki with respect to information topic Cj. The following challenge is how do we label the relationship types based on the concept we have? In other words, how do we learn M and W? In order to do that, we propose a uniform probabilistic framework based on survival theory. We introduce a pairwise transmission probability. This probability describes how likely a node I will get infected by the information at time Ti from node J, which is infected by the information at time Tj. This probability is decided by two main components. The first one is the time difference between Ti and Tj, and the second one is the propagation capacity on the link from node J to node I. And with this pairwise transmission probability, we can compute a likelihood on the overall social network this is a likelihood of all the information cascades on the network of different topics. We compute this based on a survival function and a hazard function. And this then becomes our optimization function, which we want to maximize, so that our the propagation capacity matrix M and the type assignment matrix W can be optimized to maximize the likelihood of observing our training data as the information cascades. However, this maximizing this likelihood is a non-convex problem in M and W simultaneously. So we propose two kinds of algorithms to solve this optimization problem. The first one is an EM algorithm, in which we iteratively optimize M and W. And the second one is a single optimization framework where we might make more assumptions about the data, but then we can optimize M and W simultaneously.